Notes, Advanced 5-7, Direct Variation. I'm going to tell you a synonym of direct variation is proportional. So when you have already done your proportional, deciding whether it's proportional, deciding all of this stuff and all the characteristics of a proportional, it's also a direct variation. Now they're just going to take a day and call it direct variation. So a direct variation is a linear relationship in which the ratio of y to x is a constant called k, and instead you know that is m, or slope, and you know that y over x has to equal y over x. That still applies to direct variations. We say y varies directly with x. It's a direct variation. It's proportional. So the equation is going to look like y equals kx. That's better known as slope. Or if you move things around, y over x equals k. And they always use that little cursive k. And k is the constant of variation. You also know it as slope. You also know it as constant rate of change. It is the same thing as slope. The y-intercept, remember, it's a synonym for proportional, so the y-intercept is going to be 0, still going to be a straight line. Okay? Here we go. How to determine direct variation. How to determine something is proportional. You guys are good at it. You did it the other day. You did it just yesterday. Y equals kx. That k is a number. Y-intercept is 0. Graph passes through the origin. Direct variation is proportional. Same thing as yesterday. We are now going to call, instead of can you identify whether it's proportional, we are now going to ask if it is a direct variation. I am asking the exact same thing. When it is not a direct variation, not y equals k, it's not going to look it like this, y equals kx. The y-intercept is not going to be 0, it's going to be a number. Graph does not pass through the origin. It's not a line. It's not proportional. And there's some hanging off over here with adding or subtracting. Okay, so we're going to determine whether a linear function is a direct variation. We're going to decide whether it's proportional. If so, determine the constant of variation. If not, explain why not. Okay, here we go. Having to move papers around. So, how did we decide whether it was proportional? We did y over x. Y over x equals y over x equals y over x. So, 10 divided by 2 equals 5. 20 divided by 4 equals 5. 30 divided by 6 equals 5. 40 divided by 8 equals 5. It has a constant of variation. K now becomes 5. And remember, y equals kx, so y equals 5x. Is it a direct variation? Yes, because all of these match. Yes, because direct variations are proportional. And yes, it is. Constant of variation, what's right in front of the x? A 5. There we go. 28 over 3. Some crazy number. 40 divided by 6. Not really sure what it is. And okay, so let's try to get a different way. I'm going to make a vertical table. Sorry. Yes, a vertical table. 3, 6, 9, 12, 28, 40, 52, 64. This is up by 12. These are all up by 12. Okay. These are up by 3. 12 divided by 3 equals 4. So has 4. But then we have to check 4 times 3 is 12, not 28. So the equation is y equals 4x plus 16. Is it a direct variation? Absolutely not. It doesn't have a, it has a plus 16 on the back. Does it have a constant variation? No, because it's not a direct variation. Here we go. Write an equation for direct variation. Y equals kx. Solve for the missing variable. So I'm going to take my definition. If y equals 27 and x equals 9, and I'm going to do y over x. And I'm going to say that's 27 over 9, that equals 3. So y equals 3x. Determine y when x equals 11. Gonna put an x right, I'm gonna put 11 right there. So y equals 3 times 11, 33. Okay, determine y when x is 12 if y equals 2 when x equals 5. So y over x equals k, remember? And then so 2/5. So y equals 2/5 x. So then determine y when x is 12. So we're going to put 2/5 times 12, which is 24/5, which is 4 and 4/5. And then we're going to hang out on graphs. The number of hamburgers that can be made, the number of hamburgers that can be made varies directly, here's your word that's important, with the weight of the ground beef that is used. Y over x. That's how you figure out which one's your y and which one's your x, because y varies directly with x. 5 hamburgers for 2 pounds of beef. Write a direct variation equation for the number of hamburgers that can be made from x pounds. Y equals 5 over 2x. Graph it. Where do all direct variations start or have in common? They have a y-intercept of 0. I'm going to go 5 up. 1, 2, 3, 4, 5. And, 2 over. That shouldn't be there. 1, 2, 3, 4, 5, and 2 over. And so this is my line. And I need to do tails, which is a title. So this is hamburgers per pounds of beef. This is the hamburgers. This is the pounds of ground beef. And I need 1, 2, 3, so you know what I'm counting by. So here we go. How many hamburgers can be made with 15 pounds of ground beef? So remember, I have 5 hamburgers to 2 pounds. I'm going to put 15 pounds here. Make sure that one doesn't, or that L doesn't become that. and I want to know how many hamburgers. So you actually can set this up as a proportion, and 15 times 5 equals 2x. And when you multiply that out and solve, you get x equals 37.5 hamburgers. So then it's a logical question. It's just asking you to think. Remember that our quadrants are 1, 2, 3, and 4. And it's asking, will it ever graph in 1, 2, 3, or 4? So remember, this is negative x's and positive y's. Can you ever have negative pounds of ground beef? No. Can you? This is negatives and negatives. You can't have negative hamburgers, and you can't have negative pounds of ground beef. This is positive, negative. You can have pounds of ground beef, but you can't have negative hamburgers. So that is direct variation. Remember that direct variation is the absolutely same thing as proportion.